Thank you so much for joining us today. We're really excited to have our fourth webinar in this series that's focusing on AI and family medicine and how it's going to impact primary care. My name is Andrew Pinto. I'm a family physician and a clinician scientist and direct the Upstream Lab, a research group in Toronto. And I'm really pleased to be joined by Dr. Noah Crampton, who is a family physician also in Toronto at Toronto Western Hospital. He's a clinician scientist in the Department of Family Community Medicine and a lecturer at the University of Toronto. And his focus of his research is health informatics. So we'll just go to the next slide. A few housekeeping items. This session will be recorded and we'll be posting it online. You can submit questions using the question and answer function and also raising your hand. We've found that what's worked in the past is if people post a question and then folks vote on it, and then we will be able to see which questions are the most popular. Finally, at the end, we will have a short survey that will be posted in the chat box, and that is mandatory for those who are claiming continuing medical education credits. We just want to begin by acknowledging the land on which we are meeting and working. Both Noah and I are here in Toronto, which is the traditional land of the Huron-Wendat, the Seneca, and most recently the Mississauga of the Credit River. We are very grateful for the opportunity to live and work on this land. And of course, this land is still home to many people from across Turtle Island. Whenever we do a land acknowledgement in the series, we also want to point to some practical work in this area. And I really want to highlight work by colleagues at the First Nation Health and Social Services in Manitoba and work they've been doing throughout the COVID pandemic. You can take a look at this link to look at more of their work, but I think they've also been a model around Indigenous governance and control of data and the use of it to direct actions, in this case, COVID vaccination strategy. Just to move on to disclosures. So these are my disclosures of where I receive research support and financial support, which are from nonprofit and commercial entities. One important disclosure is that I serve in an unpaid role to a startup company, Mutuo, and Noah is going to be talking a bit about the work as he's a leader in this company. Next slide. These are Noah's conflict of interest, and as he notes, he has an equity stake in an organization that we're going to be discussing. Next. And further, that he is the CEO of this startup company. And he's going to be touching on some of the technology that is being used and studied there. Next, no other conflicts, and this program has not received any specific aid. Next slide. And in terms of mitigating the very clear bias that is apparent, he's going to ensure that he gives equal time and space to talk to about competitors to the company that he is leading, and also not convey any advantages or disadvantages between his product and the competitors. And also he won't discuss the peer leader review process that's being done by Ontario MD. Next. Also, as part of mitigating potential bias, this series is led by a scientific planning committee that includes patient partners, Jane Cooney and Joanna McFadden, and also a number of colleagues, and really appreciate their time. And also a big thank you to Rose Wang, who helps coordinate these webinars as well. So I'm going to turn it over to Noah now to go through his slides, and we're going to have some time at the end for questions as well.
All right. Thank you so much for the introduction, Andrew. It's my pleasure to be here today. I'll speak a little bit about natural language processing, or NLP, as we talk about, and its role in family medicine. So the objectives of today is to describe at a high level what NLP is and what makes AI-powered NLP so powerful, provide some existing real-world examples of NLP relevant to practice, and see how we can envision potential future applications of the technology and provide possible benefits, clear challenges, and very concerning issues with its deployment in family medicine and its effect on the patient-centered medical home. So we'll start with the first poll. Just out of curiosity, has anyone ever used any of these things? Okay. So as you can see, most people have. We have the Alexa speaker on the left. We have the Google search bar, which predicts the searches. We have Siri on someone's iPhone to predict what you're saying into the phone, and also chatbots. So really interesting use cases of NLP that are in the broader world. But in fact, it's actually entering healthcare. Some of you may be familiar with a company called Babylon. Actually, in Canada, Babylon's rollout has been acquired by TELUS, and they are a sort of a triaging chatbot before they have seen by their clinicians on their platform. So they sort of respond in the natural language that patients would expect. So the core of my research is how to best leverage the benefits of AI-based language processing while sustaining and even elevating the values of family medicine. So can we use AI-based tech, including AI-based NLP, to achieve a better healthcare system? So our current system, as many of you know, is illness-focused, reactive, legacy processes, one-size-fits-all, episodic service and siloed care. Access can be complex, provider-centered, and volume-based with the uncontrolled cost and resource utilization. But in the future, the goal is really to get more health-focused, proactive, and predictive processes based on the latest evidence, individualized, continuous service, integrated, and team-based coordination with clear governance, simplified access, people-powered, and quality outcomes. And AI can be a really strong tool to do that, including AI-based NLP. So before we get into those applications, let's talk about how AI is applied to language. So NLP is a convergence of two different levels of sciences, computer science and linguistics. And AI typically leverages machine learning, as you learned in previous webinars, to bring these two together. So first, brief review of linguistics, as some of you may not be familiar or remember what that includes. So it's really the scientific study of natural language structure and meaning. So structure can include the morphology, the formation and composition of words, or syntax, the grammatical formation and composition of phrases and sentences, phonetics, the speech acoustics and articulation. And it also includes the meaning. So the semantics is about how language truthfully encodes meaning through relations between words, phrases, signs, and symbols, and what they are to represent in reality, and pragmatics, how situational content influences the production of meaning. Okay. And so in parallel, we have traditional computer science, and computer science leverages key components, as you will recall from previous webinars. There's data, discrete sort of encoded entities in computers, objects or operations. And this data, when it's aggregated, makes digital information, which is meaningful to us as humans. So in traditional computer science, you have sort of rule-based or logic-based algorithms, and the computer code just follows a set of these rules that a programmer allows, and these are typically called regular expressions. Algorithms are then aggregated to form computer programs. So in the past, most of NLP was classic statistical or rule-based computational models. And so natural language processing would leverage computational approaches to infer rules and patterns within free-form transcribed language or text, so as to convert that free-form text into some sort of structured format that's usable. And so with the traditional computer science, the rules-based, you can have sort of pattern matching or rules-based parsing of NLP. But there's, as you can imagine, language is so complex. It's extremely difficult to think of every if-then statement for language. So it wasn't so accurate. There was due to the ambiguities and the incorrect grammar, etc. In terms of AI, I won't belabor this because it's been gone into in different webinars, but in contrast to regular traditional computer science, it's combining different tools that can be programmed. So typically heuristics, optimization, probabilistic models, statistical classification, machine learning, deep learning, neural networks. So you're all familiar with these high-level concepts at this point, and it's leveraging those tools to do the processing of the free-form text. So here we are today. In the 80s and 90s, it was the switch to machine learning-based, AI-based NLP began, because the performance really became much more incredible. So pre-artificial intelligence, it was sort of like NLP was mostly in academic research, techniques tailored for individual tasks. Performance was variable because of all the data that was so heterogeneous. And after AI, there's been just an explosion of research into this, both academic and commercial. Techniques are readily adaptable to different tasks. And with enough training data, performance can be really consistently high and generalizable, and therefore have a real world value. In terms of how AI-powered NLP typically works, these sort of sequence of texts are pretty classic. There's some small variations on this depending on the application, but in general, and you can see here, this is applied to medical text. There are these very specific techniques. I won't go into detail about what they do, but essentially they cut up the phrase or sentence, and then it normalizes those individual words for the mathematical models that AI leverages, and is able to then predict the corresponding relationships. And so this is, I think, a nice visual to see how those relationships end up being aggregated in those predictions. So as you can see, like mother, boy, daughter, in the matrix, it comes close together because they know that there are some sort of semantic closeness to what they represent. So here we are with AI-powered NLP. In many cases, in the real world, we're seeing greater than 99% accuracy for this type of tool. But it does come with some disadvantages that we really have to keep forefront of our mind. To train machine learning models, significant time and effort must be spent annotating large amounts of data. Models can become overfitted to a data set, so it only is able to do well on the data set it trained on and not new data that's out there. Similarly, models trained on data such as medical records may lack generalizability because of how different the data sets can be. And furthermore, models are often difficult for humans to evaluate compared to clinical rules, which are obviously more intuitive. So these are some of the issues that in medical context that we have to be aware of. And I just wanted to highlight here differentiation with the term speech recognition. So it is a very closely affiliated field. Speech recognition or speech to text is actually the subdomain of computer science, which processes audio files. And the audio files contain verbal speaking to accurately identify the language's words in the audio recording data. Often the goal is to then convert the identified audio data to text. And in contrast, NLP is really the processing of the text itself. So just wanted to make that clear distinction, but they are very affiliated fields. So how has AI-based NLP been deployed in healthcare around the world so far? So key use cases is really includes like translating relevant medical knowledge, which may be locked in sort of unstructured medical notes. So unstructured meaning that it's free form, there's no clear categorization or classification into it, and translating that into structured data, which can then be used subsequently for other uses. And so general applications in healthcare that are quite common is information extraction from our progress notes, for instance, clinical text categorization, and summarization. So find the key concepts in a block of text. So this is not specific to NLP, but a really nice highlight of how AI can be applied to primary care. But embedded in each of these areas that we have in our practice, NLP use cases are almost in every single one of these. So if you can think of it, diagnostics, medical advice and triaging, as we saw with the Babylon, risk prediction and intervention, so processing progress notes and providing risks based on that. So there's all these different categories, and NLP based AI is actually at the center of most of these. This is a paper that was written by our colleagues out in Western University, and they did a scoping review of what sort of studies are applied using AI to primary care. And as you can see, that all these different types of functions, a lot of them require language-based functions, so decision support, treatment support, information extraction, and prominently 8.6% or 35 studies of the studies that they did in their review was a focus of natural language processing. So just to highlight some of the selection of those 35 studies, recognition of multiple sclerosis in the electronic record, medical terms that that can be linked using NLP, improving of colorectal cancer testing using NLP, measuring physician adherence with gout indicators using NLP. So as you can see, all these different use cases are out there in the literature. What's probably more practical to your cases is what are the commercial tools out there, and more digital health companies are coming out with NLP-based tools, and they may come trying to come into your clinics to market them, and we have to be very clear about what they do, what they can't do, how they've been vetted. So I'm going to be presenting examples of these, but they're definitely not an endorsement of any of them, just to be aware of them out there in the marketplace. So one of the more well-known ones is Amazon has a tool which is able to process medical notes and do all of that classification, and it's actually really quite accurate. So that's one example. Another example is Dictation Software, as you're familiar with, computer-assisted coding. So we don't, some jurisdictions in Canada code more than others, are in our patient profile, etc. And these can recommend automated codes and improving documentation. As I mentioned, structuring the unstructured information in the records, predictive modeling, risk stratification. This is an interesting one, automated registry reporting. So this is actually a use case in the US. So able to connect to those systems and recommend that there's a direct reporting that occurs. Clinical trial matching is a really neat use case, seeing if a patient is appropriate for a clinical trial. And population surveillance or real-time case or cohort finding uses NLP. So all these tools use NLP, and these are on the right are the examples of vendors who market them. Okay, this is as Andrew alluded to earlier. I'm a CEO of a very early stage pre-commercial startup where I'm trying to lead the development of what's called an ambient EMR assistant. What that means is trying to facilitate assistance with clinical documentation for physicians and use of their EMRs through AI-based tools that leverage natural language processing. I'm going to first present on our direct competitors. So this is Suki, a well-known tool in the US, becoming very popular with its ability to, as you can see here, you can ask Suki to show my schedule, create a follow note for a specific patient, etc. Here in Canada, Microsoft and Nuance are partnering up together for this similar type of tool, also known as virtual or digital scribes. So as you can see on the right-hand side, you have a conversation between doctor and patient, and on the left-hand side is the predicted medical note based on the conversation. And this is our tool called AutoScribe. And we have a similar sort of tool. So as you can see on the right-hand side, you see the note, but on the left-hand side, you have the conversation. So there's some neat areas of how we can apply NLP in the future. Let's say if we'd had it directly embedded in our EMRs or EHRs, we can do some of those use cases, the automated prediction or risk stratifications for our patients, for at-risk populations, understand when to be as proactive about interventions as possible, quality improvement use cases, supporting the dashboards. Some of you who work in Ontario may be aware of Ontario MD's dashboard that integrates with many of the EMRs to drive quality improvement. And we can sort of auto-structure some of the free text that is in our EMRs to feed into that dashboard. Automated reporting of unstructured EMR items to ministries of health. So facilitate with achieving government targets, for instance, if there's bonuses, etc. Research use cases. So this is one that I'm particularly passionate about. We can apply NLP to large population databases and really do neat studies if it's validated and accurate about many different granular issues that are that are important to primary care. Okay. So with this background knowledge, it's time to really go into what are the challenges and concerns of AI-based NLP, because this is really where the vendors are coming with these tools in the next 10 years for sure. How do we make sure that it's appropriate and aligned with the values of family medicine? So some of the challenges include the siloed data of the health system, and including the social sector, social determinants of health, and other key data is not directly linked in our system. And so NLP trained on data that's siloed is only as good as that siloed data is. There's the concern, there's this challenge of vendor lock-in of EMR data. Meaning that vendors have an interest to keep their data proprietary to themselves, even though it's owned by the patient and the clinicians are the stewards. Vendors have neat technical tricks to keep out access to that lock-in if other third parties want to develop a NLP on those data. It's an unclear return on investment for some of these tools, and our procurement regulations don't account for how these tools function in the real world. The system incentives can be malaligned, and some of you might be familiar with how it's hard. We're a country, we have a reputation of pilots, but scaling across a health system, the benefits of a tool is not clear. So, we really have to make sure that the incentives are still for the benefit of patients and patient-centered care. And right now, there's no clear guidance from especially in Canada. They're starting to be more and more about how, but that needs to be more systemic about how to procure these tools for different contexts, right? Community-based clinics, urban, rural, well-resourced, under-resourced, etc. All right, so why don't we do the next poll here? What are some of the concerns that we have about AI in family medicine, based NLP in family medicine? All right, so I think we all share many of these concerns. Some people may prioritize some concerns over others for themselves. I'd be very interested for the group that selected what other ones that they think about, because we certainly want to think about all the different risks that we should have ways to properly address them. Okay. So some of the things are exactly what we are in this poll. So I'm going to go into details on a few of these, but the first one is, that there's a lack of critical appraisal of the tools that NLP vendors and their motives are selling. I'm going to start selling more and more. There's the ethical concerns, particular focus for me that, Andrew, of course, and as we should be collectively, is how the data that the models are trained on, if they're not calibrated in their process of the development of the tools, they can perpetuate the discrimination that's historically been for marginalized patient populations. The privacy is a major issue. Obviously, sort of this is an issue that we all have to think about, and I particularly think about a lot, about how to maintain privacy and security of these very sensitive data for training the models. And one of the issues, obviously, is if you're going to be having a recording device in the clinical encounter, does that replace our medical record? Are we supposed to now be accountable for every word we utter? That's obviously a real challenge that has to be determined at a very high level in society. All right, so I want to go into more detail on the commercial interest piece. So as you know, when we do our quality improvement plans for our local context, they should really be affordable and developed free of commercial interests. But if we're using commercially sourced NLP tool, can we trust that the data that we as clinicians are a steward of remains used in an appropriate way by vendors? So some of you may be more familiar with a recent article in the Toronto Star about how one of our EMR vendors is selling their data to a third party without patient or clinician awareness. And the same can be said about companies who refuse quality improvement specialists access to EMR data. So, if the quality improvement specialists are free of those biases that we're concerned of, why are the companies not permitting access in a safe and secure way? And so, just to remind you, the College of Family Physicians of Canada had a position statement supporting the access to data and electronic medical records for quality improvement and research, full stop. And I highly encourage you to review this link to understand all the issues at play in there. Then there's the ethical concerns. So the AI-based NLP at this point, just to reiterate, refers to machine learning-based programs. These programs require a huge amount of data, typically unstructured, often unstructured data. And as I mentioned earlier, they can include inappropriate biases, so missing or incorrect data, leveraging inappropriate data sources, and thus the algorithms and their outputs will also be biased without the end user being aware of these built-in biases. So this can really exacerbate existing social inequities if textual or speech data is not calibrated. So lots of examples of AI generating negative results, for instance, for Black, Indigenous people of color. And one that I'm particularly tuned to is, speech recognition and NLP can have less accuracy for patients who have accents that are not the sort of standard North American accent. And so that can negatively affect different cultural groups. Privacy concerns is a really important one. It's obviously not specific just to NLP, but it is something that should be for every domain that we're thinking about applying AI. We should always have this top of mind. So there's a huge amount of data that we require from many different sources, and the NLP tools, to be as accurate as possible, this data will have to be somehow shared or aggregated or linked for the tool to function in the most optimal way. And we have to think of a way that we're going to permit this in a way that's still consistent with patient values and our values as a profession. So this data sharing that will have to occur to another processing area, so it requires a lot of computational power, so that's why it sometimes have to go to the cloud. It involves a set of risks with that data movement that we are just not trained as physicians, as a professional body, to know how to properly oversee. So how can we as physicians properly appraise Very important assessments that are done by our health organization. So privacy impact assessments, threat risk assessments, of digital tools using personal health information that we are stewards of. So we don't have technical training. Is there a third-party organization we can trust to do this for us before we start adopting NLP tools? And what are the patient notification and consent mechanisms needed to inform of this possible sharing of the data? So we really have to think these through, make sure they're implemented before widespread adoption of NLP in care and NLP-based tools in care occur. Other concerns, which I won't go into too much detail today, is we talked about the black box problem. So the algorithms can be so complex, it's very hard to understand how the AI arrived at its result. And another one is, if we're going to be getting all these suggestions, recommendations, workflow management options, this may become a new or additional clinical responsibility. And that's going to significantly impact our workflow. And we got to understand how that's going to do it. And we got to make sure that it has no negative detrimental effect on our workflow. So avoiding more alert fatigue, because that's just not going to help us or the patients. So I highly encourage you all to read, our colleagues in the specialty domains, the Royal College of Canada's Task Force on Report on Artificial Intelligence, because a lot of these use cases are not going to be just for family medicine. They will be applied to all of medical specialties in medicine. And Royal College has really done a nice job summarizing some of the key issues. Many are NLP based. And certainly the CFPC will have a lens on for family medicine. So, as I end this presentation, I think these are the key factors that we as a profession really have to think about when it comes to AI-based NLP. So what should it be doing? How will it best serve our patients, ourselves, our systems that we work in? Because there's a lot of opportunities, but a lot of pitfalls, and we got to be very clear about how we approach it. Vendors of NLP are going to be the primary sort of mode of how that starts to get into our practice, just like vendor-based electronic medical records were. So what should they be doing? What should they be proving to us during a procurement event? Professional bodies should oversee NLP in healthcare by doing what? So, I know, the CADIF at the national level, Canada Health Infoway, various provinces have their own sort of agencies that do this, but it's a lot of work. And are they properly resourced to do this in a way that, it's not the Wild West for the vendors and then they just go in before they have an opportunity to properly regulate this. And specifically for us, like, we have a lot of control about what should we be teaching the future generation of family doctors. This is already here, but it's in the next decade, it's really poised to transform care. So what are the sort of critical skills that we need to develop for ourselves and our trainees before we feel that we have a good grasp on all these use cases?